Electricity and circuits. Introduction. Electricity, a very important and widely used form of energy, is an integral part of our day-to-day life. Electricity is the flow of electric charge. It is a form of energy which has been converted from other sources of energy like coal, natural gas, nuclear power, and so on. These sources of energy are said to be the primary sources of energy. Some common electricity-producing devices are cell, battery, generators, and so on. The sources required to make electricity may be renewable or non-renewable, but electricity is non-renewable. Electricity can be transformed into other types of energy as and when required. Electricity is supplied from power stations to different areas. Electric cell. Electric cell is a device which produces electric current because of chemical reaction. When the chemicals in the electric cell are used up, the electric cell stops producing electricity. The electric cell then has to be replaced with a new one. A cell has two terminals, a positive terminal and a negative terminal. The outermost part of the cell is a cylinder made of zinc with a white, moist paste of ammonium chloride. At the center is the carbon rod with its top end sealed with a metallic cap. The carbon rod is surrounded by a grey granular powder of carbon and manganese dioxide. Zinc acts as a negative terminal, whereas carbon rod acts as the positive terminal of the cell. There is a chemical present inside the cell which acts as an electrolyte. This is used up in the process of generation of electricity. When it is completely over, the cell stops working. A torch is an example of a device that provides light. The source that provides electricity in it is an electric cell. It is the cell that generates power to the bulb of the torch to glow. The cell is available in many shapes and sizes as shown in the figure. A torch has a bulb, electric cells, a switch, and the outer body. When switched on, a metal strip moves beneath the switch connecting the cells to the bulb, and the bulb grows, giving heat and light. Activity: to make a simple torch. Take a torch bulb, an electric cell, an aluminium clip, 4 pieces of electric wires, and electrician's tape. Scrape about 3 to 4 cm of plastic covering from both the ends of each wire, so that metal wires are exposed at the ends. Fix one metal end each of the 2 electric wires to the terminals of the bulb as shown in figure. Use electrician's tape to fix the wires. You have 2 more free metal ends. Wrap one of the free metal end to one leg of the aluminium clip. Now, take the other 2 wires and connect them to the 2 terminals of the cell and wrap around the electrician's tape as shown in the figure. Join the free metal end of a wire of the bulb with one of the free ends of a wire with the cell by twisting the 2 ends together. Your torch is ready to work. As soon as you connect the free metal ends of the wires with the aluminium clip, the bulb will glow. Here, the aluminium clip is working as a switch. You can put your bulb on or off position by connecting or disconnecting the free ends with the clip. Electric current. The bulb glows because of the flowing of electric current, which produces heat and light energy in the bulb. An electric current has electrical energy. It gets converted into heat and light energy when the current flows through an electric bulb. The electric current flows from the end marked plus, positive terminal, through the metal wires to the end marked minus, negative terminal. Electric circuit. An electric circuit is the complete passage of electricity from one end to another end of an electric cell. The complete electric path, when electricity flows through it, is called closed electric circuit. The arrangement of electric path, when electricity does not flow through it, is called an open electric circuit. A circuit diagram is a pictorial representation of an electric circuit. At times, it so happens that a bulb does not glow even when the circuit is connected properly. This happens when the bulb is fused. A bulb is said to be fused when its filament is not intact. A break in filament results into a break in the path of electricity. Electric switch. This is a device which helps in making or breaking an electric circuit. An electric switch allows us to use electric current as and when required. Switches are seen in many electric devices and household wirings. On connecting the wires with the bulb and a cell in the correct order, the bulb starts glowing. This will continue to glow till the time the cell is not used up completely or the wires do not get disconnected. When the switch is on, the circuit is a closed circuit and the bulb glows. When the switch is in off position, the circuit is an open circuit. A complete electric circuit has these components: an electric cell, which is the source of electricity; an electric device, like an electric bulb; an electric switch, the purpose of which is to start or stop the flow of current; connecting wire, which provides the passage for the flow of electricity; electric conductors and insulators. As you may have seen, wires have a covering on them. This covering may be made up of plastic or rubber. We have to remove this cover before bringing them to use. Thus, it is clear that if the covering is there, the wire will not be able to allow electricity to pass through it. Some examples of insulators are rubber, plastic, glass, paper, and wood, and so on. Inside the covering, insulator, there is a wire which is made up of metal. This wire allows electricity to flow through it. If we try using a cotton wire, a rubber wire, or a plastic wire in place of the metallic wire, what do we see? The wire does not conduct electricity. Thus, it is clear that only metallic wires allow electricity to pass through them. On the basis of the passage of electricity, we can put all substances into two categories: conductors and insulators. Conductors are the substances that let electric current to flow through them. Insulators are the substances that do not allow electric current to flow through them. There are some materials present on Earth which are neither conductors nor insulators. They are called semiconductors. The base of modern electronic technology is semiconductors, which are used in all electronic devices. Uses of insulators and conductors. Insulators are safety devices as they prevent us from shock and electric fire. Conductors allow the electricity to flow through them, thus they provide a passage to electricity. Switches, electric plugs, and sockets are made of an insulating material. Both conductors and insulators are important in using electricity. Whenever we want to make a circuit to use electric current in some way, for example to light a bulb, we use wires made of metal like copper or aluminium, which are good conductors of electricity. We cannot use bare wire as this would be dangerous and may give us an electric shock. Therefore, wires are always coated with an insulating material such as rubber or plastic. The outer covering of switches, regulators of fans, etc. are made of an insulating material. It saves you from getting an electric shock. The electricity used at home is generated by large generators far away from the city. It is brought to our houses using thick wires. You should never do any experiment with the electricity used at home, as this can be very dangerous.